Hi, I'm Ms. Vaughan. Let's have a look at relating velocity time graphs to position time graphs. Here we have an equation y equals a fifth x minus 7 squared, and this is going to be our position time graph. And from this graph we're going to sketch the velocity and time graph. The velocity is the gradient of this graph, so we're going to find spots and draw a tangent, and whatever the gradient is of that tangent, we're going to sketch or plot that point over here. In a previous video we did original graph and gradient graphs. You might want to watch that video again so you can follow this along. It'll make a lot more sense. So let's do a table with different positions, and we're going to plot each of these points onto the table and find the gradient of these, and the gradients of these will be the velocity. And when we do so, we can see that we can sketch the velocity graph, and it looks quite linear. You'll see in future videos why this parabola becomes a linear graph. So the position time graph, find the gradient, you get the velocity time graph. Example 2, here we have the velocity time graph, and we're going to look at sketching the position time graph. Remember, the velocity is the gradient of the position. So when we put in any point, for example, this point here at 0, we have the velocity is -4. The -4 is the gradient of that graph over there. So we start over there, we start at position 0, so the -4 will look like that, so a negative gradient. But we don't know exactly what it looks like. So picking the next point, let's say at 1, we have the velocity value is -2, so the gradient will be roughly negative like that, but let's take the one before, because the one before was -4, now we're -2. So negative, but not as steep. The gradient at 2 is 0, so you see the velocity is 0, so the gradient of that graph will be 0. So we only know the gradient, but we don't know exactly where it is. So we know it's doing that shape so far. And then here we have at 3, we have 2. So the gradient at that point 3 will be positive. And the gradient at 4 is 4, is going to be positive and more steep. So it's going to do somewhat that, but we don't have values because we don't know exactly which points it goes through. We're going to have to study a few more chapters before we can interpret that. But from this video, watch it again because it's very short, but quite tricky. So in the first example, we looked at position going to velocity, where each of these points gave the gradient, so the numbers on these dots. Whereas in this one, the velocity is the gradient of that, so each of these points gave the general shape of the position time graph, or the slope of the position time graph. Thank you for watching, and I'll see you next time. Bye!